In today's notes, we'll look at using z-scores and z-score tables to calculate probabilities of events occurring. So this will help us refine the approximations we're able to get just based on the empirical rule for any distribution that's normally distributed, which is this metric bell-shaped distribution. We introduced the z-score formula in a previous note. So we calculated z-score by taking the value we're interested in, subtracting the mean, and dividing by the standard deviation. So if our data set has a mean of 54 and a standard deviation of 2.5, we can calculate the z-score for a given value like 50 by saying z is going to be equal to 50 minus the mean, and then dividing by the standard deviation of 2.5. Plugging that into our calculator, a value of x equals 50 would have a z-score of negative 1.6. Remember that z-score tells us how many standard deviations above or below the mean our value is located. A negative z-score means that our value is below the mean. A positive z-score means that our value is above the mean. Our standard normal distribution can be thought of this bell-shaped curve that has a z value of 0 in the middle and then being spread out like a number line with the values -3, -2, -1 appearing on the left, and 1, 2, and 3 appearing on the right. 99.7% of all of our values are expected to appear between a z-score of -3 and 3. Okay. So what's going to be new now in today's notes is we're going to be looking up exact probabilities in what's called a z-score table or a normal distribution table. So you'll want to make sure that you have this copy of your z-score table handy. There are many that you can look up on the internet, but we like this particular table because it shows the total probability from the left-hand side. So when we have a z-score close to -3, we see a very small probability occurring. When we have a z-score of 0, we see a probability of 0.5 occurring, and then positive z-scores appear on the back side of your sheet. Okay, how we use this table is the whole number and the first decimal place are shown in the first column, and then across the top row we see the place value for this for the second decimal place digit. So if I want to figure out the probability that we have a z-score less than -1.24, okay, again, thinking back to my curve, I can think about what's reasonable and think about what side of the z-score table I'd be looking it up on, right? I'm less than 0, so I know my answer should be less than 0.5. And to look that up on my table, right, I'm going to look up -1.2 and find the correct row to call across, and then I've got my, oops, that's the wrong column I went down there. My column is going to be 0.04, so -1.24 has a probability associated with it of 0.1075. Okay, if I want to find the probability that I have a z value less than positive 0.54, again, I can think about what my sketch would look like and what a reasonable value would be. Because I'm positive I'm greater than 0, all right, but I'm figuring out the probability that I'm less than that. My probabilities for continuous distributions are given by the area underneath the curve. So I'm shading all the area less than 0.54 on my curve, and then I can look that up on my chart. So for our charts that we're using in this class, again, positive values on the back side of the chart. So I've got 0.5, 4, And so the probability associated with that event is 0.7054. Okay. So once we get used to navigating the Z-score table, it's not too bad. It's just a matter of looking things up and checking it out. But there will be different types of questions we're interested in. So what we've looked at so far is finding the area below a particular Z-score value, and those are going to be the easiest because we can look it up directly on the table, right? So if I want to figure out what proportion of observations take values, Z values less than 1.47, again, I'm thinking about a less than. The picture that I'm drawing, the sketch that I'm drawing, the area, the probability that Z is less than 1.47 matches the image that's on our Z-score table. So I just have to find the value in the chart, 1.47, and take that value back to my page, 0.9292. Okay. So there's two other types of questions we also could be interested. So sometimes we might be interested when a value is less than a certain amount. We might also be interested in when it's between two values. Okay, if we're interested in when we're between two values, right? So maybe we're interested in the probability that our Z is between negative 1.80 and 1.40. We think about how this relates to the areas on the chart. When I look up negative 1.80, it's going to give me this area in here. When I look up 1.47, it's going to give me all the area to the left. So to do this calculation, I'm going to find the difference in those two particular areas. So to find the probability that negative 1.80 is less than my random variable and is less than 1.40, I'm going to look up the probability that Z is less than 1.40 and the probability that Z is less than negative 1.80 and find the difference between those values. So if you look up Z equals positive 1.40 on the chart, you're going to see that it comes out to 0.9192. Okay. If we do the same thing for Z less than negative 1.80, right, we're going to flip our chart over, go back to the negative side, we get a value of 0.0359. Finding the difference between those two values, my probability comes out to 0.8833. So again, when we're finding the area between two values, we're going to look up both probabilities and subtract the lower Z value probability from the greater Z value probability. Okay, and then the third and final type of question we might get asked is about being greater than a particular value. We're finding the area above a particular Z value. So if I should find out, right, what's the probability that we have values greater than negative 1.75? So I think about negative 1.75. I'm finding the probability is greater than that. Okay, and what's on the chart is the area less. But it's okay, I know something about probabilities. right? The sum of the total has to add up to 1. So if I want to find the probability that z is greater than negative 1.75, I can calculate 1 minus the probability that z is less than negative 1.75. Okay, I go back to the chart. I find negative 1.75 on the chart, and then I do the calculation. So the probability associated with z less than negative 1.75 was 0.0401, and so my final answer will be 0.9599. Okay, great work. Hopefully that's starting to make sense. And so before we move on and do some application questions, give it a try and practice. So for each of the 5 examples, okay, you're going to sketch and write a probability statement and find the final answer. Pause the video, give it a shot, and then check your answers. For part A, your answer should come out to 0.3707. I haven't shown all the work, but because it's a greater than question, you're going to look up the value on the chart and subtract it from 1. Your sketch should have the area to the right of 0.33 shaded. Let's try the next one. Question B is a less than question, so we can look it up directly from the chart. It comes out to 0.8944. And you're going to want to make sure that your area has all the area left of 1.25 shaded. Okay? Pause the video and try part C. Because this is a between question, you're going to look up the probability associated with z equals 1.00 and z equals negative 1.00 and find the difference between them. It works out to 0.6826. This is an interesting one because it reminds us of the empirical rule that the probability of having any value within 1 standard deviation of the mean is about 68%. Time for part D. The probability that z is greater than 0.50 is 0.3085. You're going to want to look up the value on the table and subtract it from 1 since it's a more than question, and your picture should have the area to the right of 0.50 shaded. And then finally, we'll look at question E. Okay, this comes out to 0.9960. We're looking for the probability z is greater than negative 2.65. We've got almost the whole curve shaded, and hence why the probability is so close to 1. Okay, so now hopefully you understand a little bit about how z-scores work, how the types of questions work, and you're starting to figure out how to use the z-score table. If you have any questions, don't hesitate to sign up for tutoring, visit your instructor during their office hours, ask some questions, and the next video we'll look at applying this idea to application questions.